Good. Thank you, guys.
It seems to take like 10, 20 seconds to actually connect with the live stream. So I'm going to go ahead and start that now. And like I say, give it by when it's officially 8:30, we should be good to go.
Sounds good.
Okay, we're connected.
All right. Good morning, everyone, and welcome to Wednesday of Wisconsin Water Week. I'm Michelle Nault, and I'll be your moderator for this morning's session. I would like to first thank our sponsor for this session, Wisconsin Lake and Pond Resource. And without further ado, I would like to introduce both of our speakers. We have both Ezra Meyer and Paul Mathewson from Clean Wisconsin. Ezra has been the water resource specialist at Clean Wisconsin since 2008. And previous to this current position, he has worked with Dane County's Office of Lakes and Watersheds and with the Wisconsin Association of Lakes. Ezra has been appointed commissioner of the Madison Metropolitan Sewage District and founder board president of Friends of the Mukwonago River. Ezra studied water resources management and urban and regional planning at UW-Madison.
Good morning, everyone.
And then his co-author is Paul Mathewson. Paul completed a dual degree graduate program at the University of Wisconsin with the Law School and the Nelson Institute for Environmental Studies Environment and Resources program. He received a PhD at the University of Wisconsin-Madison's Department of Integrative Biology, researching methods to predict the impact of climate change on animal distributions. He uses his scientific expertise at Clean Wisconsin to conduct research analysis in support of the air, energy, and water programs. And today, Ezra and Paul will be presenting on protecting our lakes and rivers and ourselves from harmful PAH pollution. As a reminder, if you do have any questions for the presenters during their presentation, please use the Q&A feature on your InventMobi platform. Do not use the chat feature. It's the Q&A tab that's a little further to the right. Type those questions in, and at the end of today's session, we'll read those out to the presenters for them to answer. We do have a full hour for this presentation, so sit back and I will turn it over to Ezra and Paul.
All right, thanks, Michelle. And I'll try to share my screen here. And okay, I think we should be good to go here. So yeah, thank you, Michelle. Yeah, again, my name is Paul Mathewson. I'm staff scientist at Clean Wisconsin. I'll be co-presenting with Ezra Meyer, our water resource specialist. And we're going to be talking about one of the topics that we've been working at Clean Wisconsin the past few years, working to protect ourselves from PAH pollution. And so the way this is structured is I'm going to give some background on the science on the issue and how it came to our attention and kind of establishing why it's something we should work on. And then Ezra's going to go through some of the policy actions that's been going on around the country and here in Wisconsin. So I'll dive right into it with some introduction to PAHs. So PAHs, it's an acronym for Poly-cyclic Aromatic Hydrocarbons. So I'll just refer to them as PAHs. They're a class of persistent organic pollutants, which means that they hang out in the environment for a long time. They don't break down very easily. And so, along with the other ones like DDT, PCBs that people might have heard of, they're just these persistent chemicals out in the environment that cause problems. There are hundreds of different types of PAHs. Several of them are known to be toxic, carcinogenic, or mutagenic to aquatic life in humans. In addition to cancer endpoints, exposure to PAHs has also been related to birth defects and developmental issues. If the mother is exposed to PAHs while pregnant, or the child while young is exposed to them. So there are things that we want to limit our exposure to. So that's why 16 of them are on the US EPA's priority pollutant list due to their toxicity once they get into the environment. And then in contrast to other well-known persistent organic pollutants, I have this figure on the right here. This is from a United States Geological Survey study back in 2005, showing the trends in a couple different persistent organic pollutants in the country. So you see DDT on the top here. They've been going down across the country. PCBs have been going down or staying steady, while PAHs have been going up. They just haven't received the same attention perhaps and regulatory action as DDT and PCBs. And so that got USGS thinking that it needed more attention. And they've done some work on that. And then another reason to address it is that contamination is costly to remediate. So PAHs do their chemistry, they bind to soil particles. And so as they get washed into waterways, they build up in the sediment and just, they kind of stick to the sediment. They don't really dissolve into the water column. They stick to that sediment and they build up in the sediment to create toxic conditions there. And in the Great Lakes area, they've spent hundreds of millions of dollars of trying to deal with contaminated sediments, which are often contaminated by PAHs, often in conjunction with other things, but PAHs are often a driver for taking action. So we spent a lot of money trying to deal with them. So if we can prevent them from getting into the environment in the first place, then we can save some money and protect health. So pH sources. So pHs are formed anytime organic matter is combusted. So there are natural sources, so like wildfires, volcanoes, they'll produce some PAHs. But in urban environments and human-dominated environments, there are a lot of human sources of PAHs running. So I have a list of some common ones from fresh asphalt, and these concentrations are milligrams per kilogram. It doesn't, the units don't really matter. I just want to show an idea of the kind of levels we're talking about. Like asphalt has some, motor oil, road dust, tire particles, and up to the used motor oil has 440. Burning wood stoves, they'll produce some. That's a common source. But the USGS research, when they were doing, they started their work in Austin, Texas. The team down there was working on it, and they found some hot spots that were around paved parking lots. And they're wondering what was going on there. And they did some testing of the sealant product. And you can see that the coal tar-based pavement sealants are at 70,000 milligrams per kilogram. So that's a couple orders of magnitude higher than any other human background source that's in urban environments. And then there are a couple of different types of pavement sealants. There's asphalt-based. They have relatively low, very low levels of PAHs compared to the coal tar-based pavement sealants. So this identification of coal tar-based pavement sealants as a source of PAHs in the environment. It started again in Austin, Texas. It's kind of led to research throughout the country, which I'll get into here. So just to cover the types of sealants again, there's three main types of pavement sealants. There's coal tar-based, which run in the order of 50,000 to 100,000. Some products even go higher than that in terms of PAHs. Asphalt emulsions are the main alternative. They are, again, much lower, 1,000 times fewer PAHs. And there's also acrylic and latex sealants, which are PAH-free. I will note, I think Ezra will get into this in his part of the presentation, that since places have started taking action of restricting the use of coal tar-based sealants, there have been alternative products coming up that are less than the coal tar-based sealants, but still significantly higher than asphalt emulsion. So there are some other types of products, but these are the three main classes that are out there of pavement sealants. So just to back up about what coal tar is and why, just kind of explain why it's so high in PAHs. So this is, coal tar is the byproduct of coke and coal. And so coal tar itself is 50% PAH by weight. So a good chunk of it is just pure PAH. And coal tar-based sealants are, 15 to 30% coal tar. So you're looking at, 10 to 20% PAHs when you, have the full mixture of a coal tar-based sealant. So coal tar itself is a known human carcinogen by the AIRC. However, here in the United States, it's exempt from RCRA, that's our hazardous waste, federal hazardous waste rule. It has a specific exemption from being defined as hazardous waste to encourage its so-called beneficial use in commercial products. And so that includes its use in pavement sealant. So through this kind of loophole, it's allowed to be used in various products, even though it is a known carcinogen. So how does sealants pollute? So again, if you're not familiar with pavement sealants, it's that black liquid stuff that's spread over parking lots and driveways to give it a nice black look, dark black look to it. Purportedly, it provides some protection against weathering for underlying pavement. So a lot of places use it as a kind of a preventative maintenance thing. And so when you spread it on, you spread it on, and then as it's, as over time, as cars drive over it, as snowplows go over it, and there's general weathering, it starts to flake off and is washed off into the environment. So here on the right, I have a picture. This is from Google Earth, Google Maps of a parking lot in Milwaukee, right next to the Milwaukee River. And so you can see in the parking stalls where there's not much wear and tear, you can still see the dark black. That's the sealant that remains, but on all the the main roadway area here, you can see it's all been scraped off. And so it's got to be reapplied every year. And so as it wears off, it's got to go somewhere. So it's washed into stormwater drains, it's washed into nearby waterways, it's blown into houses. So all those PAHs are going into our waterways, going to our homes. And so as these parking lots get resealed every few years with this very high concentration of PAHs, you have this steady fresh source of PAHs to the environment. And so I think many parking lots get reapplied every 3 to 5 years. So you can see it's a pretty quick turnover in terms of how fast the stuff is getting reapplied and lost to the environment. So this slide, again, this is from USGS work. Here in the Wisconsin team, they did a study, and so what they got interested in was looking at comparing pH concentrations in urban river sediments around the world. And so you look at Bangkok, which is a population of 6.3 million. The median pH level is 1.6 milligrams per kilogram. Look at Beijing, China. The median is 2.2 milligrams per kilogram. And then when you look at Milwaukee, a population of 600,000 people, we have a median of 36 milligrams per kilogram. So much higher than these much larger in terms of population cities. And so the question is, if PAHs in the waterways are coming from your general ambient human environment, from emissions, vehicle traffic, these cities like Bangkok and Beijing should have much higher levels of PAHs since they have more traffic, more emissions. But one difference is they don't use the coal tar-based sealants over in those cities, whereas in the US and Milwaukee, it is used. So that got them, on the idea that coal tar-based sealants are potential major source of PAHs to the environment. So in 2016, they published their study. So this is USGS study of, they sampled about 40 different sites around the Milwaukee area. So on the right here, I have all the sites are you can't really read them, but in the bolded, so you can see the kind of covers from downtown Milwaukee all the way through the outer suburbs. And so they sampled for PAHs at about 40 sites. At 78% of the sites, the concentrations exceeded the probable effects concentration, which is the threshold above which effects on aquatic life in those water bodies you can expect to see impacts from the PAH contamination. And they did some source profiling about to try to determine where these PAHs are coming from. And they use multiple different lines of evidence, because any one approach to defining where these PAHs are coming from has its limitations. So they use, like I believe it's 5 different approaches, and they all kind of converged on coal tar-based sealants being the major contributor of PAHs to the Milwaukee area water bodies. And it's about 3/4, a little over 3/4 of the PAHs are coming from these coal tar based sealants based on their analyses. And I do want to highlight, so I've circled the sites that have the highest pH concentrations. You'll see they're not the downtown Milwaukee ones. So again, if it was, if it's really coming from your general urban background, you'd expect the highest levels downtown, where you have the most vehicle traffic, the most dense emissions. But you see it on these outlying areas where you have a lot of commercial parking lots that are and driveways which are sealed with these coal tar based sealants. So this study was released in late 2016, early 2017, I believe, and then that's really what got Clean Wisconsin going on this topic, just seeing the results here in Wisconsin. They did, I do want to highlight a follow-up study that USGS did jointly with the EPA that was released last summer. And so they expanded this work to look at sediment in water bodies watersheds around the Great Lakes, all the Great Lakes states and the Canadian provinces. And again, they found that coal tar based sealants were the most likely source of PAHs in the majority of those watersheds. So not just a Milwaukee issue. They sampled sites up the Lake Michigan coast here in Wisconsin, one site over in the Superior watershed. And again, coal tar based sealants were identified as the major source. So here is just on the left here, we have a map of where they sampled. So you can see they sampled up and down the Lake Michigan coast in Wisconsin, some Green Bay tributaries, and then one up here in the Lake Superior Basin. But they also did, I guess they didn't go in the Canadian province. I thought they did Canadian provinces, but you can see they did other Great Lakes watersheds as well. And this on the right here, again, it might be too small to read, but each column here represents a different line of evidence that they looked at to look at the different sources. Each row represents one of their sampling sites. And over here on the final right-hand column is what the weight of the evidence suggests as the dominant source. Pink ones are the coal tar based sealants. So you can see the vast majority of them. Coal tar based sealants were identified through the weight of evidence as the main source. There are a couple vehicle emission ones, the green and the gold brownish ones. These are, and at those sites, vehicle emissions were identified as the major source. But the main takeaway is that vast majority, including all of the Wisconsin ones, at one Wisconsin Root River site, it was unclear. The different lines of evidence pointed to different sources, but on all the other Wisconsin sites, coal tar based sealants were identified as the major contributor of PAHs to those sediments. Clean Wisconsin, we've done some of our own sampling just because after the Milwaukee study, we wanted to see, is this a statewide issue or is it limited to Milwaukee? So we did some sampling in conjunction with some chemists from UW-Oshkosh who actually did the lab analyses, and in small cities throughout the state, just to see if the same trends came out, and we did. And so here in the inset, kind of hard to read, but these are some samples from Root River, up and down the Root River, and the blue indicates the proportion of the PAHs coming from coal tar based sealants. So you can see at most sites, coal tar based sealants are the major source. But the big picture was that in all these cities, at least one of the sample sites, we're finding that coal tar based sealants were the dominant source, and that levels of PAHs are getting to the point where you can start seeing impacts on aquatic life in the waterways. So it wasn't just a big city Milwaukee issue, it was throughout the state. Just to give you an idea of the sorts of ways that we look to see where it's coming from, we use the exact same methodology that USGS did. And so this is one example of one line of evidence. And so PAHs will occur in the environment in mixtures. And so you can look at the aggregate and look at the relative contribution of any one PAH to the overall mixtures concentration, and see how that profile compares to the profile of a known source. And so here we have 11 different PAHs on the x-axis on the bottom here, and then the relative contribution to the total PAH sum for each of these individual PAHs. And the blue line with the error bars, these are the contributions of each individual pH to the sediment samples in our Root River sampling. And then on the black lines behind it with the open circles, this is the profile from dust coming off of coal tar sealed parking lots. And so you can see it's a fairly close match. You're not going to have an exact match just because you have multiple sources, but the closer match you have, the more dominant that source is. And then you can statistically look at it with a chi-squared statistic. The lower value, the closer you are. And then if you compare it to if you look at, again, the sediment profile in blue to other possible sources, here's vehicle emission air, and so it's not that great a match. Again, asphalt is, you don't have that same match. Tire particles, pine wood burning, and another profile of gasoline vehicle emissions, and then asphalt. I guess I did asphalt twice on here. But again, this is just an example to illustrate how the profile is kind of matching what you see coming off of coal tar sealed driveways and parking lots. So I just wanted to throw an example of how we're going about identifying what the main sources are. So those are some examples of studies in Wisconsin, but this has been repeated throughout the US. The USGS did a study of 40 lakes in the US and found that PAHs contribute about 50%, coal tar-based sealants contribute about 50% of PAHs to lakes in the eastern part of the US, west of the Rockies. They don't really use these coal tar-based sealants because, again, the coal tar is coming from the steel milling areas in the Midwest, and so most of the coal tar sealants are used in the eastern US. Another study in Texas found that coal tar-based sealants contribute over 70%. A study by the Minnesota Pollution Control Agency of stormwater detention ponds in the Twin Cities found that over 2/3 of the PAHs in the stormwater ponds are coming from coal tar-based sealants, and a study in Springfield, Missouri, 80% coming from the sealants. So it's been repeated. And then also in South Central Pennsylvania, they did a watershed study, Austin, Texas, as I mentioned, Toronto. So it's been repeated over and over by different agencies, different researchers. So it's not just a one-off deal. And so yeah, there's a lot of science indicating that these sealants are a major source of PAHs to urban water body sediment. And then here's one just to look at. So again, there's the whole argument that it's just background. In urban areas, there's just urban background that's contributing. And so the USGS wanted to look at that. And so, if you look at, and so under that theory, unsealed parking lots should have they're exposed to the same background sources of PAHs. And so you should see similar levels if it's true that the urban background is the main contributor. And so they took samples from sealed coal tar sealed pavement, and then they took it from unsealed pavement, because again, if the urban background was the main contributor, then you should see similar levels. If you look in Twin Cities, unsealed, you had 570 milligrams per kilogram versus 24 for unsealed. In Chicago, 4,600 versus 21. In Detroit area, 3,400 versus 47. New York City, 1,300 versus 30. So it's really, it's that kind of helps indicate it's not just urban background when you're seeing much higher levels unsealed areas. And then when you look out west where they don't actually use coal tar-based sealants, you do see similar levels on sealed versus unsealed, because they will use the asphalt-based sealant over there, which has some PAHs, but not a lot. So, Salt Lake City, 2.1 versus 83, and Portland, less than 13, less than 8.6. And so, again, this is just more evidence showing that these sealants are a major source of PAHs. So, given that they're out in the environment, what are the implications of that? And so there are public health implications. I should have reordered the slide, but I want to talk about the science first. And so some research by USGS and researchers from Baylor University down in Texas, what they did is they looked at what is the risk for kids living near sealed parking lots or sealed driveways. And so they looked at what the concentrations of PAHs in the house dust in homes near sealed parking lots, or coal tar sealed parking lots, versus what's the concentration in the house dust near either asphalt sealed driveways or unsealed driveways. And so the house dust near coal tar based sealed driveways was 25 times higher, 129 milligrams per kilogram, versus 5.1 in either the asphalt based sealed parking lots or the unsealed ones. And so kids who are living near these sealed driveways are exposed in their house dust to a lot more PAHs. Similarly, they looked at the concentration in the soil in the front yards of these houses, of these apartment complexes, and they found that the soils had much higher levels of PAHs as well. And so when you're talking about young kids who are crawling around, putting things in their mouths, they're ingesting this dust, they're ingesting the soil, and so they're being exposed to much higher levels of PAHs if they're near these sealed driveways. And so using some calculations, they say they arrived at kids living near coal tar based sealed driveways from age 0 to age 6, they have a lifetime cancer risk increased by 14 times just by living next to those sealed driveways. And so based on that evidence, the American Medical Association back in 2017 during the annual meetings had a resolution that they would advocate for legislation to ban the use of pavement seal coats containing high levels of PAHs. And so that's obviously the AMA is a organization of medical experts who have evaluated the evidence and said that, yeah, this is a public health issue. Similarly here in Wisconsin, Children's Hospital supported taking action as well. Some other public health entities have acknowledged the risks of these sealants to young children. Health Canada, Physicians for Social Responsibility, Chicago Department of Health, Connecticut Department of Public Health, Illinois Medical Society. So you can see other medical experts have evaluated this and said this is something that we should care about from a public health perspective. There's also implications for the environment. So as I mentioned, PAHs will accumulate in soils and in water body sediment. So relevant to this conference about our waters here in Wisconsin, we want to protect those sediments and any kind of animals that are living or spending time near that sediment. And so studies have found that coal tar-based sealant runoff will kill off benthic invertebrates, reduce species diversity. So they know that forms the base of the food web. And so when you start affecting that level, you have the cascading effects upstream. So they found species loss, species diversity loss, species richness loss near coal tar sealed parking lots. They've also documented acute toxicity in fish and amphibians, especially young fish, if they're exposed to water that's been contaminated by coal tar-based sealants. Developmental and reproductive effects for fish and amphibians that are in contact with contaminated sediment, and then PAHs are also known to cause cancers and tumors and lesions in fish. So there are, in addition to human public health issues, to protect our environment and our aquatic life, it's good to keep PAHs out of our waterways. And then there's also an economic angle too. So many cities and towns will use stormwater ponds as a stormwater maintenance, stormwater runoff control. And so basically how stormwater pond works is that they have a pond and they direct stormwater into it. And in that pond, it allows all the sediment and suspended solids to settle down. And then the cleaned water is then piped out to nearby waterways. But over time, that sediment gets built up and they'll have to be dredged out and removed to allow that pond to continue working. And so if these ponds are collecting stormwater runoff from parking lots that have been sealed by coal tar-based sealants that have high levels of PAHs, that sediment is going to have very high levels of PAHs, as was found in Minnesota. I mentioned that study that found that 2/3 of the PAHs are coming from these coal tar-based sealants. And so when you have this contaminated sediment and you're dredging your pond to make it continue to work, instead of just being able to, you know, spread that sediment anywhere, you'll have to dispose of it at a landfill because it's got too many PAHs, which has a pretty significant cost associated with it. In the Minnesota, in the Twin Cities area, they estimated that if just 10% of their ponds were contaminated, it would cost them in the hundreds of millions of dollars, even in the billions of dollar range to deal with their contaminated sediment. And so right now, several Minneapolis area municipalities are suing coal tar manufacturing to cover the disposal costs under the theory that they knew that by putting it in the sealants, it's going to go into the environment, because everyone knows that's where it goes, because they have to reapply it every few years. And so, you know, you got public health implications, you got environmental implications, and you have economic implications to having this stuff used in our cities. So I've talked about a lot of the USGS has done, what some state agencies have done, just a little bit about what the US EPA has done on this. They did their own study of runoff from sealed versus unsealed paved surfaces, and they found that coal tar based sealant. So this is a very controlled setting. It's not a real world setting. It's, you know, they have experimental pavement plots where they sealed one with coal tar based sealants and another with asphalt based sealant, and they measured the runoff, and they found that 100 to 1,000 times more PAHs are coming off of the coal tar based sealant pavement surfaces than either asphalt sealed or unsealed surfaces. So experimentally, that kind of confirms what people have been seeing in their real world studies of it. And then they, in their report on the study, they said that, you know, recognizing that that cities are going to have to deal with this pH runoff, that it's probably the cheapest option is probably to ban the use of coal tar based sealants due to the pH content and the related toxic effects on the environment, rather than retrofitting the control measures to prevent that PAH runoff. And then starting in 2020, industrial facilities can't get, aren't eligible if they're using coal tar based sealants on their parking lots. They're no longer eligible for general permits for stormwater discharges. They have to either stop using it, or they have to get an individual permit just due to the recognition that coal tar based sealants are a major source of PAHs to the environment, and we want to stop that. And so based on all the science, there have been several calls to action. I mentioned the AMA one already, their resolution. The Great Lakes and St. Lawrence River Cities Initiative, they had a resolution, I believe, in 2018 to take action on this and inform member communities about this topic, and to consider implementing local ordinances to ban or restrict the use of these sealants. And then in 2017, the Milwaukee Intergovernmental Cooperation Council unanimously approved a model ordinance banning the use and sale of high pH pavement sealants in order to protect local environment and human health. And to date, I believe nearly all of the cities in Milwaukee County have adopted an ordinance in respect to that. And so Ezra will get into that and other policy actions based on the science. So I'll stop sharing and let Ezra take it from here.
All right, thanks, Paul. I've been seeing that presentation for 4 or 5 years, but it's always incredibly compelling information. I think it makes a strong scientific case. I'm going to make sure my screen is sharing here. Thanks to UW Extension Lakes Program, DNR, and Wisconsin Lakes, the Lakes Partnership, for putting on this this week of good events. Is my PowerPoint up? Awesome. So as I was saying, there's a compelling scientific case. And yet what we kind of noticed when we thought about this in the late part of 2016 was that, as compelling as all of that science is, and USGS deserves lots of credit for the great work they did. The Milwaukee Metropolitan Sewerage District helped to fund some of that Milwaukee area research. So kudos to them as well. But really not many people knew about this issue. It was being looked at in some other Great Lakes states, some educational efforts, and the beginnings of some policy efforts at the local level to do these bans on the use of coal tar based sealants. Certainly that work in Austin, Texas had begun. a number of years prior. But as we all looked at this in late 2016, a group of folks convened by Sweetwater in southeastern Wisconsin that included researchers and scientists, education-oriented organizations, and advocacy organizations, kind of all came together, and we thought something needs to be done about this issue. And eventually, I have listed here some of the entities that ended up funding a significant amount of work in the ensuing years, right up through last year, to take a look at this issue in much more depth and to start to elevate that awareness about this issue and to begin to take on that policy making work that seemed to make so much sense as a next step to build on all the good science. Just trying to advance my slide and it won't go. There we go. So we thought about strategy, as you often do at the beginning of a new campaign. And we had seen a couple of states across the country had passed bans at the state level. Minnesota was actually one of those at that time. And it had come up in the legislatures in, I think, Illinois and Michigan at the time, but not gotten passed into law. But there were certainly a lot of local government entities all around the country, especially in the eastern half, who were taking a look at this, following Austin, Texas's lead. In fact, Dane County here, where Mathewson is located in southern Wisconsin, had enacted a ban pretty shortly after all that compelling evidence first arose out of Austin, Texas. So I think that was 2008, maybe, that Mathewson, or that Dane County, I should say, passed a countywide ordinance banning the use of coal tar-based pavement sealants. So I'm going to back up and kind of walk through the process we went through thinking about strategy. So we had this sort of continuum of possible ways you can approach a problem like this. You could educate folks like we did on recycling or other issues and try to encourage better behavior. Don't use this product when you're doing a do-it-yourself job on your driveway. There's, right through sort of institutions making choices not to use it, but that would be sort of voluntary still. Government agencies could pass bans at their level, but that may not mean a regulation that affects everybody. And then there, at the farthest end of the spectrum was the sort of regulatory policy approaches, outright bans on the sale and the use of these products. So we weighed all those different possibilities and worked with all the different partners we were going to work with. Different folks fall across this spectrum in terms of where they plug in on the kind of work that they do. So we had to honor that certainly as well. A little bit of background. So there were some efforts happening around the country in some of these different sort of locations along that spectrum of action. There were efforts to work with some different institutions or institutions who just discovered this on their own and took action. So an example is the Milwaukee Public Schools. Not too long after Dane County had taken action, kind of caught wind of this issue and said, we're going to just make it a policy that we don't use these coal-based products on our schoolyards or parking lots. And there were other places around the country that were taking that same type of approach early. Sometime in the ensuing years, there were, we've never actually understood exactly why this happened, but we're glad it did. A number of the big box sort of national chains that would sell smaller quantities of these pavement sealants for more do-it-yourself scale jobs as opposed to sort of commercial operators, they phased out all the coal tar based products and started to only sell the much lower PAH asphalt and other types of pavement products, which was great. At the same time, it left out there probably the vast majority of the volume of pavement sealants going out into the environment was still going through the commercial wholesale side, where you had in the eastern half of the US a lot of coal tar based product. And there were some of these government agency bans certainly happening all across the eastern half of the country. Departments of Transportation had long since stopped using any of these products. They really are something that's more for a low traffic, low volume sort of a parking lot or driveway, not for streets and roads and highways. But they had often had policies in place that just said we won't use these products. You can see there were some other examples from Massachusetts and other places out there around the country. Paul mentioned this, but I'll bring it up because it factors into our thinking about how to approach all of this. around this time, after Minnesota passed a statewide ban on coal tar based sealants, and I have to note, it was on coal tar based sealants. At that time, that was the high PAH product. So as an attempt to regulate the PAHs, the laws literally sort of specified coal tar based pavement sealants are illegal to sell, illegal to use. That's how Austin, Texas had done it. That's how Dane County passed its ordinance. That's how Minnesota's statewide bill looked as well. And you can hazard your own guesses as to whether it was nefarious or whether it was creative, attempts to meet the market. But the companies that sell these products were beginning to create alternatives that were not coal tar based. So they met the letter of the law in those places that had rules in place, but they actually still had really high levels of PAHs. They were nowhere near as low as the asphalt based products. And so a friend we've worked with closely on this in Michigan called it the case of the regrettable substitute. So the policymaking activity out there that was happening at the local level through this time had to adapt to this reality too. So Michigan communities that were working at the local level on this began to regulate by PAH level. The attempt had to be broadened now to regulate high PAH pavement sealant products, whatever the source material they might be made out of, whether coal tar or some of these alternatives. And the District of Columbia, Washington, D.C. ended up passing an ordinance somewhere in the 20 teens that did the same thing. It used the percent concentration of PAHs in the product as the measure for what would be outlawed and what would be able to still be used. So looking at all that information as we launched in on this, we thought we'd better do the same thing, adapt, look at that newest sort of frontier of what was happening at the policymaking level. And we chose a scientifically derived 0.1% PAH content, which is what Washington, D.C. and some places in Michigan had used. And that was what we began to advocate in our work. So the second dimension to strategy was thinking about, on one hand, boy, let's just get straight to the state legislature and tell them about this problem, educate them on the health impacts, the environmental impacts, the economic impacts, just like Paul laid out, and see if we can get a bill passed. But our thought, I think, based on how limited the level of awareness was out there around the state, and frankly, mixed in with a little bit of politics at the moment, when we're talking 2017, we thought we had better start local and sort of build that awareness across the board and build up some local action to address the issue before we would go and tackle it at the statewide level. So we thought we'd really, again, back to that spectrum or that continuum of possible approaches, of course, education, but all of it driving toward local bans was our goal, bans tied to that 0.1% PAH. And then eventually when we had a critical mass of local efforts out there and had really elevated the awareness to a higher level, then we would take this to the legislature. I don't need to summarize the pitch too much because Paul's gone over it in so much great detail, but we really took that science pitch to local councils, local boards, town boards, county boards, and committees, and to the public, and just interested, environmental oriented folks in the public. But we know the bottom line sort of tagline becomes, these are predominantly used in places like Wisconsin that's so close to the steel manufacturer, but it's an easily controlled source, and there are reasonable alternatives out there. They don't cost really any different, and about half of the market is the alternatives that are far lower in PAHs. About half of the market is this high PAH stuff. To control this, to regulate this, and end up with a good outcome isn't all that hard. And you're not gonna run anybody out of business. The folks who are out there doing the application are probably using a mix of both of these different products, and they're still gonna seal parking lots. If you ban it, you're just gonna seal with the asphalt-based products. So apart from the steel, the manufacturer over at the steel facilities in Indiana and other places, there's really no economic impact directly on any business or any industry. That's how I see it. There are folks out there in the industry who might have a slightly different view on it, but we'll talk about that later. Just a little example. I think if I have time, yeah. So we we pointed out in places like the area of concern in Sheboygan, and this would be true in Milwaukee's area of concern, we have toxic legacy pollution from heavy industrial activity, and we spend millions of taxpayer dollars to clean up these toxic sediments, pull them out, dredge them out of these areas, and restore some of these waterfronts in some of our legacy, sort of industrial cities. If we're not taking care of this PAH problem on the parking lots, Paul showed that one in the estuary harbor area of Milwaukee, right next to the water body we've just spent millions of dollars of taxpayer money to clean up. We're letting PAHs just flow in, and then every 3 years we're reapplying more sealant on those parking lots. The case is pretty compelling there that we don't want to repeat these huge expenses, and especially when we know better now, thanks to the science. We talked about the economic impacts. Paul showed this slide. This was certainly a compelling part of the case we made to local elected officials and municipalities: environment, public health, and economics. This graphic is a little bit complicated, but really interesting. It shows that over time, across the bottom axis in Austin, Texas, as they sampled some of the water bodies that they were worried about from pH contamination standpoint down there, and you can see the 2006 ban comes into place, and they kept sampling these same water bodies and found that there was a dramatic drop in the pH concentrations in the sediments in those water bodies after that ban went into place and for years following that. So really sort of bore out the fact that you pass an ordinance to ban these, people will control their usage of these products, and we'll see the results in the environment, and actually in quite short order, which is great news. Certainly something that was helpful and convincing for those elected officials pondering passing an ordinance to ban these products. We talked about the calls to action. Paul's gone over this, but I'm just sort of giving you a sense of the pitch we made, or the educational outreach that we made to local communities up and down especially up and down the Lake Michigan coast and into the Lake Superior Basin as well. We had funding coming from Great Lakes funders, so that's why our work concentrated there. Not that the problem is only there, but you'll see that bear out a little bit in our maps of where we've been able to be successful. Lots of public health entities. We definitely made sure to convey that to these folks at the local level that were thinking about making these decisions. We had some great public health support in Wisconsin. We actually found some substantial amount of support from the pavement sealant industry in Wisconsin. There are both manufacturers of the asphalt-based products. We only had one manufacturer in Wisconsin making the coal tar-based products, and all the other manufacturers around the state make asphalt-based product. And then applicators are many of them are using both these products, but a significant number of them had for a number of years stopped using coal tar-based products because they knew the environmental impacts of them, they knew of the public health impacts, and they didn't like the sort of direct health impacts that their employees faced using these products. So they had phased it out. And so those folks became great advocates with us at the local level, and we'll talk about it soon, eventually at the state level. Lots of different ways we reached out to lots of different audiences on the issue to get the word out. An issue that came up with local officials and certainly staff who would be tasked with enforcing these ordinances once in place was the question of, how do you enforce this? You're not telling me we've got to deputize a whole posse of parking lot police, are you? And of course we said no. What really bears out in the places that were a few years ahead of us on this is that once you pass an ordinance, outreach and education to the public and to the industry are absolutely key. But as you do that work to make sure everyone's aware about this, focus less on policing and on finding, but just getting the word out and elevating the awareness. And it enforces itself over time in places like DC and Austin. The number of people that they were catching per year sort of went from a handful in year 1 to almost none in year 2 to 0 by year 3. They just weren't having to do a major enforcement effort around these regulations once they were in place. And it's a more detailed thing, but there's some easy methods for if you are out there as a staff person, you see a new parking lot get paved, you can test really quickly whether the product that's been used is coal tar based or is another one. And so the enforcement's actually a lower bar than people maybe initially were worried. Compliance over the years, here's what I just was mentioning, sort of borne out in some data from Washington, DC. By a few years in, there are nobody sort of violating the rules anymore. compliance is up to 100%. So after 3.5 years, all through 2017, 2018, 2019, into the very beginning of 2020, we worked with Paul and I spent a lot of time and a lot of miles all up and down the Lake Michigan coast and up to Ashland and Bayfield and Superior. And at the end of the day, building on the passage of a ban way back in 2008 by Dane County, we had worked with 24 additional Wisconsin communities to adopt these local policies. 22 of them went all the way to that stage of a ban on the sale and use of these high pH products. And then a couple counties did restrictive policies where, at least on their projects or their property, right, on county highways, county property, they wouldn't use the product. Counties were not quite in a position to regulate across the board the way that cities were. So that's what the counties did. That was Milwaukee County and Kewaunee County, I believe. Most of these ordinances passed unanimously. We did not see, a partisan divide on this issue. It didn't matter if we were working in a more red community or a more blue community or a purpley community, or even if there was a mix of folks across that political spectrum on a given council or a given board. Almost always passed in a unanimous way. So with all those 25 communities now that have passed bans around the state, we've got about 30% of the population covered, but that leaves a lot of folks out there. Here's a quick map of where those bans are in place. Thanks, Michelle. And then the last chapter of the story was, it's started but not finished. So last session, a bipartisan bill was introduced into the legislature just at the end of 2019 and was moving nicely through the legislature when COVID hit. And then it got stranded on the vine like so many things did. And when last session ended at the end of the year, 2020, it hadn't passed. And so thankfully, when this session launched in January, we saw the same Republican, they're in the majority in both houses. So Republican leaders on both houses reintroduced the bill again this session. And so it's starting to move through the process as we speak. Additionally, just a couple weeks ago, the governor included the provisions of this bill in his proposed budget for the next 2 years. So we really hope to see this bill pass with bipartisan support. It's been so widely, so well received, so widely across the state. Same in the legislature. We really think that theory of ours of building up the education and the critical mass locally really helped to tee it up for success in the legislature. And of course, I would be remiss if I didn't ask for all of your help while I've got you. So if you have a chance to talk with your legislators in both the state assembly and the state senate anytime in the coming weeks about this issue, please voice your support for their passing the statewide ban on high PAH pavement sealants. That would really help. Lots of folks work with us on this project, so I always want to make sure to acknowledge the science help that came from a whole bunch of sources, the other advocacy organizations that joined us in this work over the last several years in different parts of the state, and then lots of diverse funding from around Wisconsin and the Great Lakes area. Thanks so much. We're happy to take some questions for a few minutes here.
All right. Well, thank you very much, both to Ezra and Paul, for that very interesting presentation. I learned quite a lot myself. It's an issue I'm not really up to speed on. So really nice job laying out the science and then also laying out some of the policy angles. So we do have a couple of questions. So the first question is, perhaps I missed this, but what is the cost difference between a high PAH sealant and a low PAH sealant?
Yeah, that question's come up a lot. Commercially, we're not in the industry, so we don't have insider data on that. And so when you look at commercially, if you're to go to the store and buy a jug of one versus the other, the asphalt's actually a little bit cheaper. They kind of go up and down with the market prices, but they're comparable, if not coal tar based sealants, asphalt based sealants being a little bit cheaper. The PAH-free ones, those tend to be more expensive. Your latex and acrylic, they tend to be more expensive, but my understanding is that the lifespan is longer, so you don't have to reapply as much. So the economic difference isn't that much. And the applicators we've talked to, they said it's less than a 2% difference in the total cost if you're doing it at a commercial scale to use one versus the other. So
and it fluctuates. You know, one year you might take a look and it's a little more expensive for coal tar, and the next year you might take a look and the other one's a little expensive, but they're so close that they're essentially equivalent in cost.
Yeah, and then if you're a property owner and you're hiring a contractor to do it, the cost of the material is a certain percentage of the overall cost, and so even if it is even if the material is 10% more, your overall cost is really only going to be 1 to 2% more to do a low PAH option, even if it's a year where the coal tar happens to be a little bit cheaper.
Great. Next question, is there any preventative actions being taken to reduce the impacts of sealants that have already been placed?
Yeah.
I can go ahead if you want, Paul. I mean, on one hand, if a parking lot that's sealed is upstream from a water body and there's no stormwater pond in between to sort of mediate that flow, there's not a lot that can be done to prevent those sealant byproducts making their way into the environment. There's an extremely expensive process theoretically that could be used to sort of strip the surface off of a parking lot and go and landfill that material. We certainly haven't seen any local governments, except maybe from Washington, D.C., I think, sort of go there in terms of requiring people to do that. Let's say they find someone who illegally applies the high pH stuff. That hasn't happened too much. Maybe the good news, I mean, it's good and bad news, as Paul pointed out, but if we have stormwater ponds capturing the runoff from parking lots that have been sealed, then the sediment is going to bind up these PAHs, and then we're going to be able to dredge those out when we do that maintenance, that routine maintenance on the parking lots. And of course, there's huge expense there for the municipality or the homeowners association or whoever it is that's in charge of maintaining that, but that at least we will prevent those PAHs from making their way into the streams, rivers, lakes, etc.
Yeah, and just to build on that, some places they'll ask that they try to keep a layer of redo it, put a surface covering of the asphalt low pH sealant over it to kind of put a shell over it. But again, like Ezra said, kind of once it's out there, that's kind of a lost cause. And so this bill is kind of forward looking, stopping any future problems.
Right.
Great. Follow-up question, how can you tell if a sealant is coal tar based? This person's concerned with a driveway that they have near a lake.
Yeah, so once it's applied, they look identical. I've heard that people in the industry, they can smell the difference. But there is a fairly simple field test. If you get some paint thinner and certain type of paint thinner, and if they're interested, I think where our contact is info, we can send them stuff. But a certain type of paint thinner, you put it, you take a little chip of it and you put it in, and if it dissolves, it's asphalt or low pH sealant. If it stays solid and just kind of stains the paint thinner kind of a yellowish color, then it's a coal tar based sealant.
We've got a fact sheet we can share on that. If someone would email one of us, we can share that, and that lays out the exact sort of methodology to use to test it.
Great. Another question, this person joined a little late, so they might have missed it, but what are the biological effects of this contaminant? Is it impacting aquatic life, and is there bioaccumulation?
Yeah, so it doesn't bioaccumulate in vertebrates. I think there might be some in shellfish, like after the Deepwater Horizon pH, down the Gulf pH is built up in shellfish down there. But here in Wisconsin, our waterways, it does impact the aquatic life. It's not it's not like PCBs where it accumulates in fish and then we'll consume them through fish. That's not a thing with PAHs. Just the way that vertebrates metabolize them. But it does impact, like I said, it impacts. Studies have looked at the impact of coal tar based sealant, specifically the runoff specifically on benthic invertebrates. It kills them off. It reduces species diversity, species richness, and then it causes developmental issues in amphibians and fish. young fish, or there's aquatic, there's acute toxicity there. They did studies with juvenile salmon, and they went belly up when they were exposed to runoff. So yeah, definite impacts on the aquatic life. But it doesn't work its way up to humans as other contaminants would in that sense. So the public health, it really is limited to, not to minimize it, but it's the vulnerable population are young kids who are crawling around incidentally ingesting dust as they're putting their hands and toys in their mouth.
Mm-hmm.
Okay, there's a question on whether or not the slides will be available. I know that this presentation is being recorded. I'm assuming you guys might be willing to share out your slides too if someone sends you an email. In terms, someone asked what your emails are. Those are available through the Event Mobi platform. They can send you a message through there. Otherwise, maybe you guys can, I don't know if they'll see it if you type it in the chat, but you could try.
Yeah,
We've got a staff page on our web page that you can easily find each of us, and our phone numbers and emails are there. Just a quick Google search on Clean Wisconsin for me and Paul, and you'll find us. Okay, great. And then one more quick comment. So the bill, someone wanted people to know, is SB 152/AB 131. So just an FYI there. And then last question, we often realize that chemicals are a problem after these products make it to the market, i.e. PAH, PFAS, CFCs. How do we stop them from making it to market in the first place?
We got to adopt a European model of, just in the US, we kind of, we got to prove that it's unsafe, whereas other societies have taken the approach of you got to prove it is safe before you can use it. The US took one approach. I'm not a policy guy. Ezra might have some thoughts on how you change that whole paradigm. But yeah, that's a tough question.
We learned long after the fact about that exemption Paul detailed in his part of the presentation, where coal tar, this byproduct that's carcinogenic and pretty problematic in any way you look at it, it was exempted from our hazardous waste laws at the federal level, and which essentially was an encouragement to use it in beneficial reuse approaches like this pavement sealant thing. And so there's got to be attention paid to that level of decision making that happens at the federal level, and some similar things probably happen at the state level as well. That's where maybe the preventative step could be taken. Otherwise, we find ourselves where we are now. And of course, Paul spoke on PFAS earlier in the week, and there's another example of one where we put it out there in all these different products that supposedly make our lives better every day. Maybe they do to some extent, but also this just becomes a ubiquitous chemical in the environment that we learn later isn't good for human health or for the environment. It's the precautionary principle, like Paul said. If we could only shift our mindset in that direction more, we might be more careful on these things. Otherwise, just watching those regulatory and sort of official decisions that are made, where we let the proverbial cat out of the bag, as it were.
Great. Well, thank you both for your time today and for a really excellent presentation. That concludes this session. We have a short break now. I encourage you to go check out the different booths and virtual exhibits out there, and we will reconvene back at 10 a.m. So thank you again.
Thanks, Michelle, and thanks everyone for joining us this morning. Take care.